So this is the first question we encounter that is about section 724 and section 7.5. So this is about the elastic collision of two objects. And for these two sections, 7.4 and 7.5, the two equations we need to know is for any elastic collision without external force, there is always conservation of momentum. So P initial equals P final. Or if there are two objects A and B, that means MAVA plus MBVB equals MAVA prime plus MBVB prime. So this applies for any collision. So this is the first equation. And the second equation we need to know is equations that's specific to elastic collision. So the conservation of momentum is always true whether or not the collision is elastic, but the second equation is the relative velocity equation, or this is equation 77, and this is that the relative speed of two objects will be equal and opposite before and after collision. So with these two equations, we should be able to solve any elastic collision questions. Okay, so just a quick review. Now let's look at this question. We have a ball of mass A, now of mass 0.44 kilogram. It's moving east with a speed of 3.8 meters per second, and it has a head-on collision with another object that's initially at rest, that's 0.22 kilogram. And we want to know what is the speed and direction of each ball after the collision. So what we know is we know MA, we know MB, we know VA, and we know VB. And then we want to, this is what we already know, and we want to know what's VA prime and VB prime. So let's first look at the first equation. We have MAVA plus MBVB, and block B was initially at rest, so we can ignore this term, equals MAVA prime plus MBVB prime. So the unknown, we have two unknowns here, and we have two equations, so that should be enough for we to figure out the two unknowns. So what we usually do is we use one equation to represent one unknown in terms of the other, and we plug it into the other equation. So since equation 7.7, since what we have here is this looks like a simpler form, we will use this to do the substitution. So here again, we can ignore VB. From this equation, what we have is VB prime equals VA plus VA prime. So sorry, and then I plug this into one. Substitute 3 into 1. This gives us MAVA equals MAVA prime plus MBVA plus V prime. Okay, so if I rearrange this, what I get is VA prime equals MA minus MB over A minus MB over MA plus MB. So whole thing times VA. So now I'm plugging the numbers, and my minus MB is 0.440 kilogram minus 0.220 kilogram over 0.440 kilogram plus 0.220 kilogram. And this whole thing times VA is 3.8 meters per second. So that gives us 1.27 meters per second, and because we only have three significant numbers, we need to round it to 1.27 meters per second. So this is a positive number, meaning this is A is still moving this way after the collision. So this is moving east. Okay, so now let's find VB prime equals VA plus VA prime. So it's 3.80 meters per second plus 1.27 meters per second. And that gives us 5.07 meters per second. Again, it's positive, so it's also moving east. So that is a velocity of the of the two balls after the collision. They are both moving east and they are moving with 1.27 and 5.07 meters per second respectively.